6.1, trigonometric identities and equation. We're going to use trig identities to evaluate trig functions, simplify trigonometric expressions, and prove and verify trigonometric identities. The following needs to be memorized. You need to know these. The reciprocal identities, I hope you already know. Cosecant and sine are reciprocals. Secant and cosine are reciprocals. And cotangent and tangent are reciprocals. So hopefully you know all those. Quotient identities. Tangent is equal to sine over cosine. And I hope that makes sense to you because tangent is y over x. Sine is y over r. Cosine is x over r. So that's where you get the y over x. The y from the sine, the x from the cosine. Cotangent is a reciprocal tangent, so it's cosine over sine. You need to know Pythagorean relationships. Sine squared plus cosine squared is equal to 1. 1 plus tangent squared of an angle is equal to secant squared of an angle. And 1 plus cotangent squared of an angle is equal to cosecant of an angle. You also need to know these even functions and odd functions. Even, odd. So take a look at them, make sure you know them. So if cosine is equal to negative 1/3 and theta is between pi and 3 pi over 2, we want to find the tangent of theta. There are multiple ways to do this, okay? Your book uses identities, but it's not the only way to do these type of problems. If you wanted to use identities, remember, that secant is 1 over cosine. And I don't know why that's moving, but and 1 plus tangent squared is equal to secant squared. So if we know that cosine is negative 1/3, we know then that secant then would be negative 3 over 1. So now I have secant. And if we know secant, we can find tangent. So if we know that secant squared is equal to 1 plus tangent squared, then we can figure out that 1 plus tangent squared is equal to negative 3 squared, because that's secant squared. Solving the equation, we have tangent is equal to the positive or negative the square root of negative 3 quantity squared minus 1. Negative 3 squared is 9, minus 1 is 8. But remember which quadrant we're in. We're in the third quadrant because it's between pi and 3 pi over 2. So since we are in quadrant 3, tangent is positive there. So it's positive radical 8. Which is 2 radical 2. Okay? So there's tangent, I found it. Another way we could do the same problem is, see if I have it there. No, I didn't. Yes, I can. No, I didn't have it. I'll show you how to do it because I think the other way is a little easier. If cosine is that ratio, I'm going to draw a picture. I'm in the third quadrant. Whoops, I don't know why that moves. But it is. Sorry about that. I'm in that quadrant there. Cosine adjacent over hypotenuse. Oops. Okay. The adjacent side is my negative. You can find this missing side there by a squared plus b squared equals c squared. So negative 1 quantity squared plus, call this y squared, is equal to 3 squared. 3 squared minus 1 squared is 9 minus 1 is 8. So you get radical 8. And radical 8 is 2 radical 2. And in this quadrant it's negative. Okay? So now tangent is opposite over adjacent, so negative radical 8 over negative 1 is positive radical 8, or 2 radical 2. So either way, I don't care which way you do it, but you will need to do these identities in other problems. But you could also draw it out and do it kind of like we did in the last chapter. Find the remaining trigonometric functions of x given that tangent is 1/2 and secant of x is radical 5 over 2. Remember all the definitions. Okay? So if I know tangent, you should know cotangent right away. Reciprocal. So it's 2 over 1. Secant and cosine are reciprocals. So if secant's radical 5 over 2, cosine is 2 over radical 5, or 2 radical 5 over 5. Okay? Now let's figure out what quadrants we're in. Remember that tangent is positive in the first quadrant and the third quadrant. Secant is positive in the first quadrant and the fourth quadrant. So I have to be in the first quadrant. That's where tangent and secant are both positive. So we have to be in quadrant 1. So just remember that they're all going to be positives. Okay? So I have tangent, I have cotangent, I have secant, and I have cosecant. So I have almost, I'm sorry, I don't have all those. I have cotangent, cosine, tangent, and secant. I don't have cosecant yet, and I don't have sine yet. You know that 1 plus cotangent squared of an angle is equal to cosecant squared of an angle, right? And you know that sine, whoops, sorry. Why did I have that there? You know that sine and cosine are reciprocals of each other, and I didn't use this 1 plus cotangent here. And do I have it right here? No, yes I do. 1 plus cotangent is 2, so 1 plus 2 squared is equal to cosecant squared. Okay, and keep going with that. So 1 plus 2 squared is 5 is equal to cosecant squared. Take the square root, you get plus or minus, but I'm in the first quadrant, so it has to be positive. So cosecant is radical 5, and sine is 1 over radical 5, and if you get the radical out of the bottom, it would be radical 5 over 5. So there are all the trig functions. Next one. Another way is you can use your knowledge and draw the picture, basically. Use your knowledge that says, okay, tangent where it's positive, first and third quadrant, secant where it's positive, first and fourth quadrant, so I have to be in the first quadrant. Okay, so if I draw a little picture here, and I'm in the first, whoops, I don't know why it's doing that. Sorry about that. Tangent is opposite over adjacent, and secant is my hypotenuse. Don't know why everything's moving. I'm sorry about this, but it is. So that's radical 5. This opposite's 1. The adjacent side's 2. And again, I apologize for the picture. I don't know why the triangle is doing that, but it is. So I have 1. I have 2. I have radical 5. Okay? So that's what the picture looks like. X is 2, y is 1, r is radical 5. So that's what I have right here. And then by the definitions, just plug in what you know. So 1 over radical 5 is radical 5 over radical 5. Whoops. This one is 2 over radical 5, which is 2 radical 5 over 5. This was a given one of 1/2. Cotangent's reciprocal, which is 2. This was given. Okay? And cosecant is my r value, which would be radical 5 over my y value, which is 1, which gives me radical 5. So I'm done. Simplify. sine of y is equal to cotangent of y. We know cotangent is cosine over sine. So I have sine of y times cosine over sine. These cancel out. So I end up with just cosine. And I'm done. That's it. Next one, simplify. Cosecant of y is equal to 1 minus cosine squared of y. I hope you know that 1 is equal to sine squared plus cosine squared. So if I take this first Pythagorean relationship, I could write it as sine squared is equal to 1 minus cosine squared, or cosine squared is equal to 1 minus sine squared. Okay? Any of those three ways I could write it. 1 minus cosine squared will be sine squared. So all I did is a replacement right there. Okay? And I used that right there. Okay? That's all I used, that Pythagorean relationship. I just move the cosine squared to the other side, and you get sine squared is equal to 1 minus cosine squared. Okay? I hope you know that cosecant is 1 over sine squared. So I have 1 over sine squared times sine squared. So that was just the replacement. They're reciprocal functions. Sorry. Now it's erasing. Okay? And so that's just cancels out, so the answer is 1. I'm done. Next one. Tangent of x times the quantity cotangent of x plus tangent of x. I'm going to distribute. And when you distribute that, tangent times cotangent is 1 plus tangent squared. Okay? And that was tangent and cotangent are reciprocals of each other. Okay? And then 1 plus tangent squared is equal to secant squared. Look at your Pythagorean relationships. So it's secant squared. And like I said, that's your Pythagorean relationship. And you're done. Simplify cosine of x, cotangent of x, plus sine of x. Okay, when you're doing this, you know that cotangent is cosine over sine. So I did a replacement there. So all I did was a substitution. And then I wrote it as cosine squared over sine of x plus sine of x. Okay? Don't think I have anything else here. No, I don't. And then, whoops, I showed you everything. I didn't mean to show you everything, but that's okay. This is not the only way to do it. It's just one way to do it. I didn't have to do it this way. I did a substitution here. 1 minus sine squared is cosine squared over sine squared plus sine. This I can write as two fractions, 1 over sine minus sine squared over sine, which is sine, plus my sine. These two cancel out. I have 1 over sine, which is cosecant. Not the only way I could have done it. I could have taken this right here and, whoops, hold on. And this is not working at all to write on, I'm sorry. I could have taken this and gotten a common denominator and multiplied top and bottom by sine. And so then I would have sine squared over sine. And then I would have had cosine squared plus sine squared all over sine. Cosine squared plus sine squared is 1. So I have 1 over sine. So another way to do it, same problem. So like I said, you didn't need to do that way. You could have taken cosine squared of x over sine. This isn't working. I'm really sorry. I could have taken this, common denominator there, multiply top and bottom by sine. I get sine squared on the top, sine on the bottom. And then write it as one fraction, cosine squared plus sine squared, all over sine. Cosine squared plus sine squared is equal to 1. So I have 1 over sine, which is cosecant. So that's just another way to do it. Example 7. Secant of x minus 1 times secant of x plus 1 minus tangent squared of x. Multiply out, FOIL it, first inner outer last, and you'll get secant squared of x minus 1. So right here I will get secant squared of x minus 1, okay? And then I have the minus tangent squared of x. Secant squared minus tangent squared, if you look at it, it's like I can do a substitution if I want with some of them, but let's see what I can get the best substitution. We know that 1 plus tangent squared is equal to secant squared. I know that secant squared minus tangent squared is equal to 1, okay? So I could do something like that. So what I did is I rearranged these. Instead of secant squared of x minus 1 minus tangent, I just did secant squared minus tangent squared minus 1. Secant squared minus tangent squared, if you rearrange that, is 1. So I have 1 minus 1. 1 minus 1 is 0. And you're done. You could have done another substitution and it still would have worked. I could have put, instead of secant squared, I could have put 1 plus tangent squared, and I would have had 1 plus tangent squared minus 1 minus tangent squared. That's equal to 0 too. So that works too, and they're both right. Next example. Simplify 1 over the cosecant of x plus 1 minus 1 over the cosecant of x minus 1. So I have 1 over the cosecant of x plus 1 minus the fraction 1 over the cosecant of x minus 1. We want to get a common denominator. So I would multiply this by cosecant of x minus 1 on top and bottom. And here I want cosecant of x plus 1, top and bottom. So I'm really multiplying by 1. So that's what I'm going to do first. Okay? So when I multiplied it out, I'll have cosecant of x minus 1 over this here. When I FOIL it, you have cosecant squared of x minus 1. And then this term right here, I have cosecant of x plus 1. And on the bottom, I have cosecant of x squared minus 1. Let's make it one fraction. Now I have the one fraction. Okay? So I have the one fraction. So there's my denominator. And on the top, you have cosecant of x minus 1 minus cosecant of x plus 1. And you'll get plus 2. So here's what you're doing. Basically saying minus that. So it's cosecant minus the x. If you distribute it, you make that a plus. It distributes. Okay? So I have cosecant of x positive, cosecant of x negative. They cancel out. I have a negative 1 and a negative 1, and you get negative 2. Identities. Cosecant squared minus 1 is equal to cotangent squared. So I'll have cotangent squared on the bottom. Okay? And I hope you know your reciprocal identities. Cotangent and tangent are reciprocal identities. So this is just negative 2 tangent squared of x. And you're done. There will be 2 more parts to this section.